Welcome to Module 2 of Essential Python Scripting for GIS. Now that you know what Python is and how it fits within the context of desktop GIS, let's spend some time learning some of the fundamentals of working with this popular scripting language. Of course, just printing Hello World is not enough. You want to do more than that. You'll want to take some input, manipulate it, and get something out of it. We can achieve this in Python using constants and variables, and we'll learn some other important concepts this week. A Python script is a sequence of instructions. The structure and arrangement of the instructions are referred to as syntax. Python uses a variety of language elements to create these instructions, including data types, statements, and functions. If you think of a Python script as a recipe, the data types are the recipe's ingredients, and the statements and functions are the recipe's instructions. You need ingredients and instructions for a recipe just as you need data types and statements for a script. Let's talk about some basic data types. Comments are any text to the right of the pound symbol and are mainly useful as notes for the reader of the program. You should use as many useful comments as you can in your program to explain assumptions, explain important decisions that you made, explain important details, explain problems you're trying to solve, or even problems you're trying to overcome within your program. Code tells you how, and comments should tell you why. An example of a literal constant is a number like 5 or 1.23, or even a string like this is a string. These are called literal because we use their values literally. The number 2 always represents itself and nothing else. It is a constant because its value cannot be changed. Numbers are mainly of two types, integers and floats. Note there are no separate long types. The integer type can be an integer of any size. A string is a sequence of characters. Strings are basically just a bunch of words. You will be using strings in almost every Python program you write. Single quotes can be used to specify strings such as "quote me on this." All white space, i.e. spaces and tabs within the quotes, are preserved as is. Strings in double quotes work exactly the same way as strings in single quotes. Here's an example. What's your name? The use of the single quote in what's necessitates double quotes so that Python will read it correctly. You can also specify multi-line strings using triple quotes. You can use single quotes and double quotes freely within the triple quotes. Here's an example where you can see all three types of quotes being used. Strings are immutable. This means that once you have created a string, you cannot change it. Sometimes we may want to construct strings from other information. This is where the format method is useful. A string can use certain specifications, and subsequently the format method can be called to substitute those specifications with corresponding arguments to the format method. Observe the first usage where we use 0, and this corresponds to the variable name, which is the first argument to the format method. Similarly, the second specification is 1, corresponding to age, which is the second argument to the format method. Note that Python starts counting from 0, which means that the first position is at index 0, second position is at index 1, and so on. Notice that we could have achieved the same using string concatenation, but that is much uglier and error-prone. Also note that the numbers are optional, so you could have also written it like this, which will give you the same exact output as the previous program. What Python does in the format method is that it substitutes each argument value into the place of the specification. Since we're discussing formatting, note that print always ends with an invisible new line character, so that repeated calls to print will all print on a separate line each. To prevent this new line character from being printed, you can specify that it should end with a blank, or you can end it with a space. Variables are examples of identifiers. Identifiers are names given to identify something. There are some rules you have to follow for naming identifiers. The first character of the identifier must be a letter of the alphabet, uppercase or lowercase, or a Unicode character, or an underscore. The rest of the identifier name can consist of letters, uppercase or lowercase, Unicode characters, underscores, or digits 0 to 9. Identifier names are case sensitive. For example, my name and my name are not the same. Note the lowercase n in the former and the uppercase N in the latter. Examples of valid identifier names are I and name underscore 2 underscore 3. Here's some examples of invalid identifier names. Variables can hold values of different types, called data types. The basic types are numbers and strings, which we've already discussed. Others include Boolean statements, lists, and objects. Python is dynamically typed language. Variables are bound only by an object, and the object can be of any type. If a name is assigned to an object of one type, it may later be assigned to another object of a different type. White space is important in Python. Actually, white space at the beginning of the line is really important. This is called indentation. Leading white space or spaces and tabs at the beginning of the logical line is used to determine the indentation level of the logical line, which in turn is used to determine the grouping of statements. This means that statements which go together must have the same indentation. Each such set of statements is called a block. We will see examples of how blocks are important later. Typically, you will have one logical line per physical line of code, meaning that each line is one action for Python to perform. One thing you should remember is that wrong indentation can give rise to errors. For example, when you run this, you will get the following error: indentation error, unexpected indent. Notice that there's a single space at the beginning of the second line. The error indicated by Python tells us that the syntax of the program is invalid, and the program was not properly written. What this means to you is that you cannot arbitrarily start new blocks of statements. How to indent. You should use 4 spaces for indentation. This is the official Python language recommendation. Good editors will automatically do this for you. Make sure you use a consistent number of spaces for indentation. Otherwise, your program will not run or will have unexpected behavior. Now that we've gone through many nitty-gritty details, we can move on to some more interesting stuff, such as control statements.